Hey, what's up, guys? It's Nick White. I do tech and coding stuff on Twitch and YouTube, and everything's in the description. Doing all the LeetCode problems, got a ton of them up, so go check those out, please. And we actually have this one's called threesome closest. That's the one we're doing right now. Sorry, I just got a phone call, but it says, given an array of nums of n integers and an integer target, find three integers in num that sum closest to target. So, we're given an array of integers and we want to add three of the numbers up, and we're given a target too. So if we have 1, we want to find the sum of three of these elements that gets closest to 1. The sum that's closest to target is 2, so that's these numbers right here. That's pretty much it. Return the sum of the three integers. You may assume that, so we're returning the sum that is the closest to the one that we want. You assume each input would have exactly one solution. Okay, so to do this, the optimal solution is actually pretty slow. It's like O of n squared, which kind of stinks, but it kind of has to be. So it's kind of just we're looping through and adding three numbers each time, and then calculating the sum and of three numbers, and then we're doing that for every possibility pretty much, and making sure that the sum is as close to possible as the target. So if we calculate every time we compare three numbers, if the difference between that current sum and the target is less than the one we already have, we'll just update it. And that's the whole problem right there to do it. And we'll use actually pointers to make this more optimal. So let's just start implementing it here. So first thing we're going to want to do is say get our first little calculation here. So nums of 0 plus nums of 1 plus nums of nums dot, it's nums dot length minus 1. So that'll be our result, and then we're actually going to sort the array. So arrays.sort num, that's the built-in Java sort, and we're sorting it because we're going to put a pointer at the end. We're doing the two-pointer technique for kind of adding two numbers and getting close to a target, except we're doing it with an extra loop. So we're going to do this basic for loop to get to nums.length minus 2. That's in a lot of algorithm problems, just so we could add three numbers at once. And we're doing that loop, and then we're going to set our pointers. So our A pointer is going to be set to I plus 1, because we're going to have one element after the current index that we're looking for, and then our B pointer is going to be at the end. And you'll see this and how this works in a second. Nums.length minus 1. And then just like all these other pointer problems, well, A pointer is less than B pointer, and we're just, the only difference is we're doing this within a for loop. So we're doing the two-pointer technique, except with every possible I. So the for loop will loop through the whole thing, and we're also doing this inner pointer loop too. We'll calculate a current sum here is equal to nums of I plus nums of A pointer plus nums of B pointer. In the B pointer, the nums of B pointer is going to be the highest element, and nums of A pointer is going to be one of the lower elements. Nums of I will be the lowest element at first, and the nums of A pointer will be the lowest elements after that. If current sum is greater than target, then we will if current sum is greater than the target, then we're going to want to decrement our B pointer, because that means we want to get closer to the target, and our B pointer, nums of B pointer, is going to be the greatest element because we sorted the array. Otherwise, we'll increment our A pointer. Hopefully this makes sense. It's a little tough to explain. And that's pretty much it for the pointer loops. We just have to get closer to the target, we want to pick a smaller number in our addition, because this is going to be one of the greatest elements, this is going to be one of the smallest elements. So while we calculate our current sum each time, we want to choose some to get closer. If the current sum is greater than target, we're going to want to try an element that might be less in value, so by decrementing the B pointer, otherwise increase in value if it's smaller. So that's pretty much it, and then all we have to do is keep updating this result variable that we initially set So if math.abs of current sum minus target, the difference between the current sum that we calculated, because we're trying all of them, is less than math.abs, the difference between the result and the target, which is the initial thing we set, then we're just going to update results with current sum. All right. And that's going to give us the closest sum to target, and then obviously after all this loop we just return result. So it's just in worst case O of n squared problem, first try, solution submitted. Hopefully you guys kind of understand that and why we have to do the 2 pointers with every combination of numbers, just to try all just because we have 3 numbers, it has to be O of n squared. So we try every I is looping through everything, and then A and B, the A and B pointers within that outside for loop are going to kind of be getting us closer and closer to the target sum that we actually want. So that's pretty much it, and then we return the result, we update everything. Sorting helps us with that, and that's pretty much it. Check out the other problems. Let me know in the comments below if I did an okay job explaining this, and thank you guys for watching. See ya.